Hello everyone, welcome to your last lab of the semester, and actually probably last video too. Okay, so our last experiment is household acids and bases. Now you've already kind of seen this with the last experiment. Some everyday chemicals are acidic, some are basic. So, you know, soft drinks are acidic because of the dissolved carbon dioxide. So you have things around your house that are either acids or bases or neutral. Neutral things are quite rare. Okay, we'll talk about those in a little bit more detail soon. So, you know, in your house, you have drain cleaner, which is quite basic. You have vinegar, which is quite acidic, things like that. Okay, so, you know, we can actually examine these chemicals. We can study household acids and bases. So, you know, obviously go to the canvas, download the experiment. Here it is. Okay, what I'm going to do, I'll basically give you my pre-lab that I would normally give you in class, okay? And then, you know, you may have seen it already. I've actually uploaded a video showing me doing a little bit of the experiment, so you can actually use that. And, you know, later on, I've also got a data table kind of filled out for you. Maybe you've already downloaded that too. Okay, actually, it's a good idea if you want to look online on the discussion area and just download the appropriate documents before we start the pre-lab. That might be good, because then you can just kind of fill things in as we go. All right, so household acids and bases. Acids and bases. All right, so in your lab, should we have done this? We would have done three things, okay? We'd have done what's called a litmus test. And that's a simple piece of paper that changes color in the presence of an acid or a base, okay? So it's kind of a yes or no test, all right? We're not going to do those, but there are you know, videos online if you want to see it. It's just basically red would turn blue in the presence of a base and blue would turn red in the presence of an acid. So always associate red with acid and blue with base. Okay, have we done that? Now again, I'll show you the data sheet later. You would have got these results here, okay? Okay, then turns out back in the day before litmus paper was invented, cabbage juice, you can actually go down to the store and you can buy some red cabbage juice. You can squish it, get the cabbage juice, and it will be one particular color in an acid and one particular color in a base. And again, on the data sheet, we've kind of got that there. So it's red or green is the color. Okay, you're going to tell me which one's acid and which one's base later. All right, so if you like, cabbage juice back in the day was old school litmus. All right, now the difference between the two is a litmus test is non-destructive. You can just dip this piece of paper in your solution, it doesn't damage it, right? However, cabbage juice, once you throw in a shot of cabbage juice, it's over, right? So this is a destructive test. So this, you can't reuse your sample. This one you kind of can. All right, so these are both yes or no tests for the presence of acids and bases, okay? And then the last one, maybe you've heard of pH, right? You can actually find the strength of the acid or the base, right? So find the pH of solution. Not only will you tell the acid or base, yes or no, if it's an acid or a base based on number, it could also tell you the strength, okay? Is it a strong acid or a strong base, okay? We'll talk more about the pH scale as we go and how we can actually work out the concentration of acid, if you like, from its pH. All right, so simple one first, okay, litmus. Real simple. Red turns blue if a base, or if you like, blue stays. There's two types of litmus paper, red and blue, okay? So a nice way to think about it, if it's a base, it turns blue or stays blue, okay? So you just dip this paper in the solution, it will turn red or blue. That's a litmus test. Then the other one, there's two styles of paper, and blue paper turns red if an acid. So we associate red with acid. So the appearance of the red color is the presence of an acid. Or if you dip a red one in there, again, two kinds of paper, red stays red. So on your data sheet, I tested both kinds of paper. So if we look at this vinegar, we know maybe vinegar is acidic, right? So the blue litmus turns red, makes sense, right? And the red stayed red. Fair enough. All right. So you can just tell from the table there which are acids and which are bases from the color of litmus. It's a yes or no test, remember, okay? And you can answer questions, right? So in the back of the book it says which are acids, which are bases, and you can tell just from the color of the litmus paper. All right, fair enough. Now, as we mentioned, cabbage juice is old school litmus, right? So turns, or you know, it's naturally red, or it turns green. And the question for you guys is, which color goes with which designation, right? So is the red one acid or is the green one acid? Turns out you can look back, and maybe we'll kind of give the game away here. So the cabbage turns out, it stays red or it turns green, right? We have the vinegar, which we talked about, which is an acid because it's red in litmus, right? It's also red in the cabbage juice. So it looks like if the cabbage juice stays red, then, you know, it's an acid, all right? Okay. And then we see other things and their colors, okay? So you can kind of link this to this, right? Okay. Okay, now it doesn't turn blue, it turns green, okay? But red is acid. In the case of the cabbage juice, green is base. So I guess we kind of gave that away, didn't we? All right. All right. So again, that's a destructive test, right? So that's not so great. These days, we use, you know, litmus paper. Or if we want the actual pH, we can use pH paper, which is kind of nice. Okay, but that gives you a shade. Shades are kind of hard to see, shades of color, all right? So if you want the actual strength, pH allows us to find the strength of acid or base. Now, show you a couple of pictures. This is a nice easy picture. I just got it off the internet like literally 10 minutes ago, right? So the pH scale neutral pH, okay, neither an acid or a base. Physiological things like pure water, blood, milk, things like that, things that are in your body basically, or just, you know, pure water also in your body, right? They're neutral, they're neither acids or bases, okay? So pH 7, and you may know the trick. The lower the number, if I go down to 1 or 0 here, it's more acidic, okay? If I go higher the number and it goes from 7 to 14 on the high side, 7 to 0 technically on the low side, more basic, okay? Acidic means more H plus ions. Basic, of course, means more OH minus ions, okay? So in the middle, it's kind of a common misconception. People say, oh, it's neutral, there's no H plus in it. That's wrong. It turns out there's equal numbers of H plus and OH. It's kind of one of these deals, right? So as one goes up, one goes down. At neutral, there's exactly the same amount of acid and base, H plus and OH minus. When it's basic, there's more OH minus. When it's acidic, there's more H plus. So it's kind of like a seesaw kind of deal there, okay? So more H plus this way, more OH minus that way, but they kind of go up and down in kind of a linked way. All right, so things that are acidic, well, most fruits contain acids of some kind, okay? Vinegar, tomatoes, apples, lemons, etc. Okay, and then stomach acid contains HCl, so that's really strong. Okay, so citric acid, formic acid, acetic acid is vinegar, all natural acids found in fruits. Okay, over here on the base side, ammonia used to clean floors, drain cleaners, soap, and baking soda. Okay, so those things are basic. The further along it is towards 14, the stronger, the more OH. Okay, so we can just measure the pH. Now, what I'm going to suggest you do is kind of pause here and look at how I measured the pH of some solutions, okay? And make sure you have this chart with you, okay? So what I want you guys to do is download this. I'll do it as a document, okay? So you can download it as a doc and you can actually type it in. If you have like Word on your computer, you can just type in the numbers here, right? So I'm going to show you how I measure the pH of vinegar, a soft drink, and detergent, and you can actually fill in the numbers like you do in the experiment, okay? And we'll pretend we already did this in class, all right? So we did this in the experiment already. We did these other ones. I don't have these in my house, right? So you can fill in these numbers. And if you like, when you do the questions later, you can, if you like, full answers, right? When I say full answers, the answer is not 7. the answer is milk had a pH of 7, right? So write descriptive full answers, okay? And there's like 5 or 6 questions after the table if you look at our sheet, okay? So check out the video, all right? Then, very simply, I find it, excuse while I fumble around here. Here is the actual data sheet. Now I don't mind if you do it by hand. If you want to do it by hand and fill this out, fair enough. But I kind of already did the hard work for you, right? So it's the same table, right? Okay. And these are the questions. So you've got 5 questions. So literally all you're handing in is this one sheet, right? Okay. You can either fill it out by hand, take a photo, save it as a PDF, email it to me, or, you know, you can handwrite on this one, save it as a PDF if you want, or you can, you know, probably better type out the answers of 1 through 5 there. Okay, so do that. Complete post-lab questions. Now, a little bit more detail on pH. If you do look at the last packet online, okay, it's our kind of review packet. There's a little bit more you need to know about pH, and this is kind of a nice scale. So this is actually in the last note packet. You can take a peek if you want. But as you can see here, if we look at pH, and these are the same samples we saw in the last one. So there's vinegar, for example, there's blood, right? So there's neutral. And pH, because it's called pH, it has something to do with H plus ions, right? It's actually measuring the H plus ion concentration. As they go up, and don't be confused, as numbers get smaller in the power, it's a negative power. So that's a tenth, that's 100, that's 1,000. So it's a negative power. So numbers are actually bigger this way in terms of a real number. Okay. So as the H plus concentration increases, and we go in this kind of power, so tenth, 100, thousandths of a mole per liter. All right. And as we go kind of more on the basic side, we're still measuring H plus, but it's super tiny. So that's 10 to the minus 8, 10 to the minus 9 is a billionth. 10 billionth, 100 billionth, trillionth of a mole per liter, right? So as we remember, so here the OH is going up and the H plus is going down. On the other side, it's H plus is up and OH is down. But we're measuring each time H plus, that's why it's called pH, right? So this is the actual concentration. This is the concentration of H plus in solution. Now, what I want to kind of bring your attention to is the fact that there's a relationship between, let's just look at neutral here, the concentration of H plus and the pH. So for pH equals 7, concentration of H plus equals, let's just call it 10 to the minus 7, right? Do you see a relationship there? Okay, how would I convert pH to concentration, or how would I convert concentration to pH? It's just you take the power, change sign. Now that's all I need you to remember for Chemistry 100. If you did Chemistry 101 or something, change the sign is minus, right? So you multiply by -1, and then take the power is log. So the negative log of the H plus ion equals the pH. And that's what P in pH means. It means take the negative log. All right. So very simple, Chemistry 100. If I want to convert between concentration and pH, I just remember, hey, concentration is the pH raised to a negative power, or just take the number, remove the minus, that's the pH. So here's a question for you. If something is pH 12, what's the H plus ion concentration? If you said 1 times 10 to the minus 12, you are correct. One more, then no more. If I have an H plus ion concentration of, let's go the other way, 10 to the minus 6, what's pH? pH equals 6. All right, so that's what I want you to know. Just moving forward, that's something we would do in the syllabus, which is not in the notes. So there it is. All right, I'll attach that to your note packet. All right, so just to wrap this up, okay, complete this by May 11th, right? And that goes for all material. This is the last thing you're going to do. Your final packet's been up for a while now, right? So complete everything by May 11th, okay? And then the final exam, well, it's not really a final, it's the second midterm, which acts as a final. Second midterm, just stuff from the last one forward. I'll give it on May 13th, right? So I'll let it go for the whole day on May 13th, midnight to midnight on May 13th. I'll send it to you as an email attachment and you send it me back within 24 hours. So that's as simple as that gets. Okay, again, more details at the website for that. All right, so that's your final lab. Okay, get it back to me before the 11th and get ready for your last exam. Okay, any questions in the discussion?